Right now, wherever you are sitting, the universe is being unusually kind to you. The air is exactly the right thickness. The temperature is gentle. Gravity holds you softly. You are living inside one tiny, perfect bubble of conditions, and you never even notice it. But step outside that bubble, and space stops being a place and becomes hundreds of them. Space is not one single thing. It is a collection of the deadliest environments that exist, and each one would end you in a completely different way. Some would kill you in a single second. Others would take hours, keeping you wide awake. So tonight, we are taking a tour from the empty air above your head to the edge of a black hole, and I will tell you exactly what dying in each part of space would truly feel like. It is stranger and far more haunting than any movie ever showed you. Stay with me. Let's begin with the closest part of space, the empty vacuum just above the sky. It starts only 100 kilometers up. That's shorter than many people's morning commute. Step out there without a suit, and here is the first surprise. You do not explode, and you do not freeze solid in an instant, no matter what the movies told you. What actually happens is much quieter and somehow far more unsettling. With no pressure squeezing your body, the water on your tongue and eyes begins to boil, not from heat. It boils because there is simply nothing left to hold it as a liquid. Doctors call this ebullition. Your soft tissues slowly puff up like dough that is rising, but your skin is tough and stretchy, so you swell up, yet you stay in one piece. The real killer is your breath. The moment the pressure drops, the air is torn from your lungs. Try to hold it in, and your lungs would tear. So your body empties them for you. Then your brain, starved of oxygen, gives you about 15 seconds of useful thought. 15 seconds. Then a soft, painless faint. And after that, nothing at all. And this is not a guess. In 1966, it happened to a man right here on Earth. NASA technician Jim LeBlanc was testing a suit in a vacuum chamber when it sprang a leak. He stayed conscious for 14 seconds. His last memory was the saliva bubbling on his tongue. They flooded the chamber with air and saved him. He walked away with just a sore ear. So the vacuum is fast and almost gentle, which, as you'll see, makes it one of the Kindest deaths. Now let's drift much farther out, far from Earth, far from any star, the deep dark. Out here, the temperature is roughly minus 270 degrees Celsius. That is only a few degrees warmer than the coldest that anything can ever be. So you would flash freeze in a heartbeat, right? Actually, no. And this part is truly eerie. Cold can only steal your heat by touching you, through air or water or metal, but empty space touches nothing. There is no air out here to carry your warmth away, so your body loses heat the slowest way possible by glowing it out as invisible light. You would actually stay warm for a surprisingly long while, cooling over many long minutes, which means the cold never even gets the chance to be the thing that kills you. Your air runs out first. You would suffocate, fully awake, long before you ever froze. And that is the real horror of the deep. It is not the cold, it is the waiting. No ship in sight, no sound, no up and no down. Just you and the endless silent dark. You would have long, clear minutes to think about exactly where you are. The emptiest place your mind can imagine, taking its slow, patient time with you. Hold on to that feeling, because by the end, it will matter more than anything else here. Let's land somewhere now. Mars, the rusty world we all dream of colonizing one day. From orbit, it looks almost gentle, a red desert sleeping under a soft pink sky. But take off your helmet on Mars, and two enemies strike you at the very same moment. The first is the air, or rather, the lack of it. It's under 1% as thick as Earth's. That is so thin, it sits below a line scientists call the Armstrong limit. Below that line, the pressure is so low that your body's own fluids boil at your temperature. So on Mars, the same thing that struck in open vacuum begins. Your spit and tears boil away. And what tiny bit of air exists is useless to you. It is almost pure carbon dioxide. The second enemy is the cold. On an average day, Mars sits near minus 60 degrees Celsius. Near the poles in winter, it can plunge to 125 below. So you'd be boiling and freezing at the same time, gasping at air that cannot save you. You would collapse within a minute or two on a beach of red dust that never wanted you. Mars is not a cozy second home waiting quietly for us to arrive. It is a frozen desert that treats a warm human body as a simple mistake to be corrected. Now for the planet almost everyone underestimates. Venus, Earth's evil twin. It is nearly the same size as our world, and it is the closest thing to hell we have ever found. As you drop toward the surface, the first thing to reach you is the heat. Venus holds steady at around 465 degrees Celsius everywhere. That is hot enough to melt lead, and it never cools down, not even on the night side. Then the air itself begins to crush you. The pressure down there is 90 times Earth's. It is the same crushing weight you would feel almost a kilometer beneath the ocean, and the clouds wrapped around the whole planet are not made of water. They are sulfuric acid, so on Venus you would be roasted, flattened, and dissolved, all at the very same time. We know precisely how brutal it is down there because we actually tried to visit. In 1970, the Soviet probe Venera 7 touched down and lasted just 23 minutes. A later probe, built as tough as a deep-sea submarine, held on for around 2 hours. Then Venus crushed it into silence, the same way it crushes everything else. No machine we have ever built has survived the surface for long. A human would last mere seconds. Venus doesn't just kill you, it makes sure there is nothing left to find. Let's push the heat to the ultimate limit. The blazing surface of the sun. The sun's surface glows at about 5,500 degrees Celsius. But here is the twist. You would never actually reach that surface to be burned by it. Long before you arrived, the heat pouring off the sun would boil you into pure gas. Your body would pass from solid to liquid to vapor and simply cease to be. You wouldn't crash onto the sun, you would evaporate into it like water flicked onto a stove. And strangely, that fiery surface is not even the hottest part of the star. The sun's thin outer atmosphere, the corona, blazes at over 1,000,000 degrees. It is one of the great unsolved riddles in science. The outside is hotter than the surface. And in the core, hidden fusion burns at 15 million degrees, the furnace that lights our days. The same gentle star that warms your face on a summer morning would erase you instantly. It would not even notice you were there. You would be less than a spark against a bonfire. The sun is not cruel. It is simply so vast that your entire life is beneath its attention. Now to the largest planet of all, and maybe the strangest death on this whole tour, Jupiter. Jupiter is a colossal ball of gas, and it hides a nightmare that has no floor. If you fell into Jupiter, you would keep falling and falling and falling, because Jupiter has no solid surface to land on. None at all, anywhere. The beautiful cloud tops just slowly thicken into a bottomless ocean of crushing gas. As you sink deeper, the weight of everything above you presses in harder and harder. Soon the pressure is thousands of times greater than anything you'd feel on Earth. It would crush your body flat long before you ever found something solid to stand on. But the planet is not done. Deeper down, the pressure climbs to millions of times Earth's, and there it does something that sounds impossible. It squeezes gas until it becomes liquid metal. An ocean of glowing metallic hydrogen, hotter than 6,000 degrees, with no shore. So Jupiter would crush you, cook you, and swallow you in a plunge that simply never ends. There is no ground on Jupiter, no bottom, no landing, only deeper and deeper and deeper. It is the one place where the falling itself is the death. And now, the final stop, the most extreme object that exists, a black hole. Here, it is not heat or cold or pressure that gets you. It is pure gravity, gone insane. Picture falling in feet first. Your feet are now closer to it than your head, so your feet are pulled far harder than your head. And that difference begins to stretch you. Gently at first, then more, then violently, like a thread pulled tight from both ends. Scientists actually have a name for this. Stephen Hawking called it spaghettification. You would be drawn out longer and thinner, exactly like a strand of pasta. Near a small black hole, that pull is billions of times stronger than Earth's gravity. You'd be torn into a thin ribbon of atoms before you even reach the edge. But here's the part that breaks the mind. A giant black hole is gentler at first. Fall into a truly enormous one, and you could cross the point of no return feeling nothing. You drift calmly past the edge, unaware, with the whole universe still glowing behind you, and only much deeper, far too late to turn back, would the stretching finally begin. A silent, peaceful fall into the dark that ends by unraveling you, one atom at a time. It is the quietest violence in all of physics, and you would never see it coming. So we have toured the whole hostile map. Now the real question, which death is the worst? You would probably guess the Sun or the crushing endless depths of Jupiter. But those are the fast ones, and a fast death, strangely, is the merciful one. The Sun erases you in a blink. A black hole is over before your mind can even react. The true cruelty is not hiding in the violent places at all. It waits in the empty one. Drifting alone in deep space, you don't burn, you don't shatter, you are not crushed. You simply stay awake and clear and completely aware with long, empty hours ahead of you. The most terrifying thing about space was never the fire or the cold or the gravity. It was the silence and the time it gives you to understand exactly where you are. Remember that feeling from the deep dark? That is the one that should truly haunt you. So let's come all the way back home, back to wherever you happen to be sitting right now. That gentle air, that soft, quiet gravity, that perfect, forgettable temperature. You are resting on the one tiny island in the entire cosmos that seems built to hold you. Every other place we visited would kill you in seconds, in minutes, or in one endless afternoon. And yet, knowing all of this, astronauts still choose to leave this safe little bubble because every single one of them comes home saying the exact same impossible thing. When you finally see the whole Earth from out there, hanging alone in the black, you understand, for the first time, just how rare and fragile this one kind place really is. They call it the overview effect, a quiet shift inside you that never fully fades. So here is what I would like you to do tonight. Take one slow breath and really feel it. Feel the air arrive. Feel how warm and easy and generous it is, asking nothing back, because in every single other part of this universe, that one breath is impossible. You are alive in the only place that allows it. Try, tonight, not to take that for granted. The stars are beautiful, but almost every one of them would kill you without a second thought. Home is the rarest thing out there, and you are lucky enough to be standing in it. Next time, I'll show you what would happen if you tried to breathe on a moon made of ice. It's stranger than you think.